When we started the SDA 3 years ago, the word sustainability was not really in vogue. So I really had to start every presentation with a definition of sustainability. And today I stand here 3 years later, and I start this presentation still with a definition of sustainability. Why? Because the word has been used so much in today's communication and publicity and marketing that I think it's really important to reiterate that it's not just about environmental sustainability, but it's about the balance between the needs of the environment, economics, and society. And even further, to start with an educational part, there's another word that's very important, that's much more important than sustainability itself, which is sustainable development. Sustainable development is really about how do we balance these three aspects, society, economy, and the environment, and leave the world behind the same way we found it for the next generation. So if you have children like me, you identify a lot with this statement. This original statement comes from a report that's relatively old by now. It's 1987 from the United Nations, the Brundtland Commission. The other thing that came out of the report that I'm pretty sure you've all seen by now is the Sustainable Development Goals. They're usually everywhere. So that was the educational part. What does that mean for the SDA, and what does it mean for the larger IT community that the SDA often represents? It means we have to figure out a path, how we can digitalize more, so have more software, more digital applications, more sensors, more self-driving cars, but without negative environmental and social effects. And that's really difficult, and I'm going to talk you through that today. But before we go there, there's another aspect that I need to cover, which is the question, who says it's not sustainable right now, right? If we look at press releases, at big tech companies, at their sustainability commitments, it's really confusing, because based on that, we should be fine, right? Google has been carbon neutral for more than a decade. So what is the problem? Can we not just digitalize more? It's all positive. And ultimately, doesn't software make everything else more efficient? When I normally speak at these events, I do a survey. Today, I can't do that, but I can tell you that most of the time, if I ask people if they believe the digital sector is already sustainable, they say no. So I still have a reason to be here today. And I hope you feel the same, that there's still a lot more that we can do beyond these simple claims and statements. So where do we start? And I'm a software engineer myself, so of course, we start with Lord Kelvin. To measure is to know. So the first question is, how do we put our finger on the negative impact from IT? How do we actually measure the environmental impact that comes from a search, a shared service, an application, a website, a database? And in order for me to explain that to you, I need to take you a little bit on a journey so that you can understand the thinking behind it. So when I started building software about 15 years ago, the IT world looked a bit like this, right? So you had an application that is sitting on a server. The server is in a data center. I know where the data center is. I probably even know what kind of server it is. And then there is somewhere a network in between to connect the user with the application and the data center. Now, every 2 to 3 years later, came another layer of abstraction. Again, if you are in software, you know that's a very common path. So we first had the servers and data centers, then came virtualization, the first abstraction. Now, today we talk a lot about containerization, which is sitting on top of the virtualization layer in most cases. And the latest hot shit in IT, serverless, which, funny enough, still sits, of course, on a server. But functions and serverless computing is the latest generation of abstraction. Now, then came another level, which is basically the complete abstraction of the data center in itself, which is, we know in the cloud today, we call it availability zones, but an availability zone can actually be one or multiple data centers. But it created this perfect illusion of infinite resources, that I can build software on cloud infrastructure, and there will always be more resources. And I'm sure maybe a lot of you are using Microsoft Azure. Often they run out of resources, so maybe they need to work a little bit more on illusion seeking. Now, if we want to measure the environmental impact of this physical infrastructure that is powering our software, it's incredibly complex, right? Especially if you look at all these layers, you don't know which data center you're in necessarily. You don't necessarily know on which physical server you are. You don't know in which country sometimes the server is located, depending on your infrastructure. So it's very, very complicated to say, well, this server is running this application today. So the first thing you have to do, and that's what we did at the SDA some time ago, is to come up with a simplified way of looking at this. And I know when I show this to you, a lot of IT people are going to usually throw bottles at me or boo at me because it's very, very simplified. But I beg you to just come with me for a second. I'll explain it a bit. So starting at the bottom, digital infrastructure produces resources. We call them at the SDA digital resources. You probably know them as compute, memory, storage, and network. They're the computational primitives that we often refer to, like I said, as digital resources. Then you have another layer, which is resource provisioning. So there's some kind of system or software in place that allocates resources to an application. And then you have an application that actually consumes these resources to provide a product or service or an experience to the user. And this model is so powerful because you can apply it to almost any IT environment. Let me give you some examples. If you are on a laptop or a smartphone like this, you have the laptop or the smartphone is the digital infrastructure. It generates resources. You have an operating system that allocates these resources to an application and also deals with parallelization and things like this. But this model, there's one example, so that can be on a laptop, can also be a car, of course, with a server inside, where the server inside the car is the digital infrastructure, and then there's some software allocating resources to the different dashboards and applications. But this, of course, also works for a data center, where the digital infrastructure is maybe 10 servers in a data center that are virtualized. So this model can be applied to everything. And the most powerful idea of this model is the idea that there is a resource going around, right? This idea of a digital resource. Because if you talk to environmentalists and sustainability experts and people who make life cycle assessments, they will always tell you the same thing. Software does not exist in physical space. So if it doesn't exist in physical space, how can it have an impact, right? How can it have an environmental impact if it doesn't exist? However, as everybody knows in the field of IT, software does consume compute, memory, storage, and network, so digital resources, which have, of course, an impact when they're made, right? In the end, a server or computer does nothing else but convert raw materials, metals, rare earths, and electricity into computational power, into these digital resources. So whatever materials and electricity are being used to make these resources, that's the environmental impact of the software. So a lot of theory, but if I have this idea of a digital resource, and I can assign an environmental impact for every unit of computation, memory, storage, network that is being generated, I can also measure a lot of things within the infrastructure, and I can be very, very transparent about utilization rates, about the amount of digital resources that I'm really using, and I can also be very transparent towards the user. And I'll come back to that as a concrete example for Mercedes-Benz at the end, how that can work. Ultimately, when I can measure the environmental impact of these digital products through the digital resources, then I can also measure the total impact of the entire digital economy, because all of a sudden I can say every software application consumes this many resources, and each resource has an environmental footprint that I can use. Now, again, that was a very important part. That's the model of measuring. Now we can measure it, but that still doesn't tell us how to make the digital sector, how to make IT sustainable. And sustainability has always two elements. It's what I said in the beginning, it's this balance, but there's also this idea that somebody needs to be responsible for the environmental footprint that is being created. For a car, I think that's relatively easy. The manufacturer is responsible to a large extent for the car itself, and then you have the user, and this is the same in the digital space, who's responsible for the sustainable use of the product. If I have an electric car that is charged with renewable energy, I still shouldn't drive it in a circle just for fun. That's unsustainable use, I would say. And the same is, of course, true for software. The second one is more interesting. So if I make digital products, if I make software, if I make an application, a service, however you want to call it, I have a few responsibilities. A, I should be transparent towards the user of how many resources and how much environmental impact went into providing the product and the service. I should also make sure that I use as little resources as possible to provide the service. And I should, of course, source sustainably made digital resources. If I'm in the resource provisioning layer, so if I'm, for example, in the field of virtualization, then my responsibility is to avoid waste, to remove waste from the system, to ensure that the infrastructure is not being underutilized. And if I'm in the infrastructure part, it's, of course, my responsibility to produce sustainably made digital resources. A good example of that in the data center space is a data center. There's one in the Netherlands, for example, that is connected to a greenhouse, reuses the heat, uses only recycled hardware, and tries to make sure that the resources it generates has no additional footprint for Earth. Now, a little bit of what we do. So if you have very clear responsibilities, then you need to create some tooling around it, and that can be very vast. Here are just some examples. We work on best practices for users. We also work on best practices for digital product manufacturers, so to say, for people making software, but also a label so that you can differentiate different products. We work on optimization strategies to reduce the amount of idling resources you have in your infrastructure. And we've also released a roadmap as well as a label for digital infrastructure providers to understand what they need to do to become sustainable. Just some examples. Another aspect that I think is important that we talk about that is the idea of what do we want to contribute to the digital world. And I think, not wanting to be political, but when I currently look at the digital space, and again, I come from tech and IT myself, we talk a lot about sovereignty, we talk about security, we talk about data privacy, we talk about isolation in that sense. And I just want to remind us always on the right side is the values of the European Union and also of Germany, of course. And I feel like it would make a lot more sense if we try to be the ones who bring sustainability and bring these values into the digital world rather than, so to say, building our own ecosystem. Yeah? It's definitely the harder challenge, but I think it's what we can bring to the digital world. Is this idea of sustainability, of peace, of democracy, of human rights and freedom in the internet. So that was the very abstract SDIA part. And I promised that I will bring 5 concrete examples or a few concrete examples of what can be done in the case of Mercedes-Benz, for example. And again, you're probably going to want to throw beer bottles at me or any other form of bottle. But I highlight a few things that I think everybody can do. The 5 things that I want to share with you that I think we can do now as an IT community. The first one, you heard it probably already, I'm still going to use the same example, is an idea that I think can be very much taken from how modern cars work. If I hit the gas pedal aggressively in my car, I can immediately see on the dashboard a change in how much battery I have left, how much electricity I'm consuming. Same when I turn on or off a feature in the car, such as climate control, I can see the impact it has on my energy use in the vehicle. And this is important because it enables me as the user or as the customer of the car to change my behavior. Right? So I can do something, I can drive less aggressively, I can turn off the AC again. And I want to propose to you to set the same goal and the same transparency, the same level of control for digital products and software as well. So at the moment, if I use a piece of software and I turn off a functionality, I don't see an effect, even though it probably might have an effect somewhere, but I don't see it as a user. Also, when I perform a complex operation, let's say I run payroll in my SAP system, or I run an export, a large export from another system, I often see that I have to wait, and this waiting is often annoying, but I don't see the impact that this is creating. So how much storage is being used? What's the environmental impact of that storage? How much energy is being used? And what are the environmental costs of my actions? And the idea here is to really make sure that we don't end up in a world where everybody's pointing at IT and says, look, we have such a big infrastructure, can we just reduce it? But to make clear to people that this infrastructure exists to serve users who perform certain operations. And if we want to turn something off, we first have to educate users on the infrastructure that they're implicitly requiring through their usage. So being transparent towards the user, I think, is absolutely key, and it's the very important starting point. The second aspect that I think is really important, and I'm sure that when you design embedded systems and systems for the vehicles, you already know this, but in enterprise software and cloud-based software and backends and all these larger applications, we see this, that they're consuming more and more resources, and I believe it would be very useful if we reintroduce these constraints that we used to have in IT, when a system didn't have a lot of memory, or didn't have a lot of compute, or not a lot of storage, and we had to make it work within that constrained environment. I think it's important that we really always ask, how much more resources are we willing to expand to deliver a certain feature, a certain functionality, and really think about, do I need it? Can I somehow make this a bit more efficient? Can I build more functionality with less resources, or reduce servers, or reduce energy use? Introducing these constraints, I think, is very, very, very important. The third idea, it's been our idea on our roadmap, but I included here a picture of how ABN AMRO, a bank, does it, is classifying workloads. So if you look at most enterprises, you already have in the presentations often this confidentiality rating, and this is basically the same, but it is for IT applications. Does this application need to be always on? Can it be turned off? Can it be run partly off? Can it be run default off? And this helps the people who are responsible for running the applications to perform optimizations, to know what is critical, what is not. I always use a very good example from my mom, actually. My mom has a WordPress blog, and I researched a bit, and it's running on a WordPress provider that's quite large. And the ultimate data center where my mom's blog runs on is classified as tier 3. So that means it has redundant diesel generators, it has battery backup, it has a lot of infrastructure to make sure that my mom's WordPress blog never goes down. And I would question that that blog is so important that it really requires this much infrastructure. And I think we can ask the same about a lot of IT systems within an enterprise, within a lot of companies. Do they really need to be all sitting on the same high availability, high redundancy infrastructure? Do they need diesel backups? Can we maybe do it with a load balancer? Do we need it running in 3 different data centers? Do we need to treat everything the same, or can we provide graduations between these different application availability levels? So that's a very useful one also for your IT ops, if you have any, to optimize the applications. Now a bit more macro, and maybe also a bit of a crazy idea. One of the biggest issues in computation and in servers and data centers and cloud even is the amount of utilization of these assets. So you produce a server, it costs a lot of resources, it costs a lot of metal, but also rare earths, right? A server, if you don't know, contains almost every chemical from the periodic system, every element from the periodic system. So these are really sophisticated machines. And then the average utilization rate around the world of servers in data centers is about 15%. So we have 75% of servers are being underutilized, of computation that is underutilized, and that's something that needs to be urgently addressed, right? We would never run power plants in our society with only 15% utilization rate, and we would also not build a new one. So the crazy idea, I promised, is when cars are charging or idling, and now I know that most of them have relatively strong computers inside, maybe there is something that can be done with this computational power. Maybe some log files can be compressed or pre-analyzed, or maybe we can do more computation on these systems when it's a good time, instead of having all this computing power basically driving around, not being utilized to its full potential. That's just food for thought. It's a complicated problem, but it's still worthwhile to solve. The last one, which is always a point I try to make, especially for large companies, because you have a lot of power over the IT sector. Ultimately, it's about demanding transparency. So if you have suppliers of cloud infrastructure, of data centers, of server equipment, of chips, of cables, whatever you procure, let them give you a full lifecycle assessment of these of what you're buying, because eventually you will need that data anyways to report your own Scope 3 emissions. So you want the full environmental impact of everything you buy, and you can demand that from the suppliers that you work with. The second aspect, as a really big one, is repairability. And I think Mercedes-Benz especially is a very interesting example, because I know for a fact that you can order of almost every Mercedes ever made, you can still order spare parts, even original parts from Mercedes-Benz. Why can't I do that with servers? Why does the firmware get somehow expired and then all of a sudden I have to buy new servers just because the firmware doesn't work anymore, but I can still actually run the server and the server is still in a good physical state? And I don't think that we should accept that. I think, especially with the end of Moore's law, chips are not getting faster anymore. Memory densities are not getting higher anymore. A server that I bought last year will probably be okay for the next 10 years. And we should maximize the lifetime of these assets. They contain a lot of resources, and a lot of infrastructure is needed to manufacture them. And yeah, we should utilize them to the fullest extent possible. And the last one is again about transparency of software. If you buy applications from third parties, if you use software as a service, or you have suppliers building software for you, again, ask them to provide the full lifecycle data of the environmental impact that is associated with making these software products. Eventually you will have to account for all of it within Mercedes-Benz Scope 3 anyways. So ask them for a lifecycle assessment. It will trigger an enormous amount of transparency on the environmental impact of software, which I think will not hurt us at all.